So here we have the first problem in our dynamics review. This problem asks us to find the height of a rocket that has been launched with the shown velocity profile after 5 seconds, as well as the peak acceleration of the rocket. So if we take this problem, and we know that our height is equal to the integral of the velocity over time, because we know that our velocity is equal to the change in height over change in time. So to find this integral, we have two separate functions, but we just need to evaluate each of those functions over the appropriate time domain. So this one goes from 0 to 2, this first section here, and then this section here goes from 2 to 13, but we really only want to go to 5. So we're going to say our height at 5 seconds is equal to the integral from 0 to 2 of 20t plus 10t to the third power. That becomes our first equation, plus the integral from 2 to 5 of our second equation, 140 minus 10t dt. So from that, we're going to get our height at 5 seconds equal to the integral of this first portion of this polynomial. We have 20t squared over 2 plus 10t to the fourth over 4. Again, this is going to go from 0 to 2 plus 140t minus 10t squared over 2. Again, this is going to evaluate from 2 to 5 plus some constant of integration. So if we write each of these out, the first portion here, we can plug in our 2. So 2 squared is going to give us 4. So 4 times 20 divided by 2. So that should give us 40. Plus 2 to the fourth power is 16. So 16 divided by 4 will give us 4 times 10. That's another 40. Right? Minus, each of these is going to give us 0. So 0 squared times 20 divided by 2. So that gives us the entire first term there. Right? Plus at 5, we have 140 times 5. So I'll pull a calculator out there. 140 times 5 gives us 700. So 700 minus 10 times 5 squared. So 5 squared gives us 25. 25, 120, or 250 divided by 2. So 125 minus 125. That's the first person. Minus 2 times 140. That'll give us 280. Let me put this in parentheses. Minus a negative. 2 squared is 4. Again, times 10. Divided by 2. That gives us 20. Plus c. And we know that at height is equal to 0, time is equal to 0, height is equal to 0, our constant should go to 0. So we shouldn't have to worry about that, really. Let's start adding these up. So 40 plus 40, that's 80. Plus we have 700 minus 125. So that'll give us 575. And minus 280 minus 20. So that'll be 260. This whole thing all together is going to give us, let's see here, 575 minus 260 plus 80 should give us 395 feet. So that should be the answer for our first part there. Basically what this is telling us that the rocket traveled up 80 feet in the first 2 seconds, and then it went up another, what is it being, 315 feet in the last 3 seconds of what we were looking at. And because it was at higher velocity for a longer duration of time here, right, in that last 3 seconds. And really it's just the area under this curve, right, up to that point. All right. The second part of this problem wants us to find the peak acceleration of the rocket. Now, this could be fairly difficult if we want to solve this just analytically, because we could actually try and find the maximum. But if we know where the maximum occurs, then this is fairly straightforward, right? And the maximum occurs when the slope is the highest, and the slope is highest just before this 2 second mark. So what I'm going to do is we know that our acceleration is equal to the change in velocity over change in time, right? So if I know that the peak occurs at that point, I can look at the acceleration at 2 seconds and then plug that into my velocity, or really my change in velocity over change in time, right? The derivative of my velocity function at that specific time. Right, at 2 seconds. So the derivative of this is going to be 20 plus 30 t squared. And if I solve for that at 2 seconds, I get my acceleration equal to 20 plus 32 squared. So this will be 4. Oh, a little mark there. So 4 times 20, sorry, 4 times 30 would be 120. So our peak acceleration should be 140 meters per second squared. So hopefully that should be reasonably straightforward. And let me know if you have any questions.